Okay, here's a question from section 4.2 in the textbook where you are asked to graph this polynomial function, one of these ones. Let's maybe start with question number 15 and see if we can graph that. They say in here to use the instructions on page 311, and here I've just written them down here. So if I want to graph that, first thing I would look at is look to see what kind of thing it is. Looks like it's a quadratic. So I know a quadratic either goes up like that or goes down like that. The positive in front means that it's not this one, it's one of these. So I have a graph that goes up. So first, over here in the instructions, it says use the leading term test to determine the end behavior. Well, the leading term test is looking at that leading term. It's an even, so it starts high, ends high. It's a quadratic or squared, so there's just one bump, okay, or one term. So I got that part. Find the zeros of the function by solving that. Okay, so here's my function. H of x is equal to x squared plus 2x minus 3. And they want me to find the zeros of the function. And to do that, I let y, or f of x, or in this case h of x, equal to 0. Equals x squared plus 2x minus 3. To find zeros, if it's a cubic or a quartic one, I might have to use synthetic division. If it's a quadratic like this, I can probably just factor that. I think this one is factorable. So it's x and an x. I think plus 3 and minus 1 will do the trick. X squared minus 1 plus 3, that'd be plus 2. 3 times that's minus 3. So that checks out. So it's factored. Now I use the zero property. So x plus 3 is 0, or x minus 1 is equal to 0. So in this case, x is a minus 3. In this case, x is a positive 1. So at a positive 1 over here somewhere, and at a minus 3, right over in here somewhere, it'll cross the graph. So it has to look like this, and it has to cross the graph in those 2 points. Okay, 2's done. X-intercepts divide the axis into intervals and choose a test point in each interval to determine the sign of all functions in that interval. So what they're saying is to take and look at this interval here and see whether the graph's positive or negative. Look at this interval and see it's plus or minus, and look at that interval there. Well, you can sort of do that, but if I know it's a quadratic like this one, I know the shape has to be something like this. So I know that if I take any point below negative 3, it's got to be a positive number. It's got to be up high here. And you could try that. You could plug in, say, why don't we plug in a negative 5, for example. So negative 5 squared is a positive 25 plus 2 times negative 5, that's negative 10, so that's 15 minus 3 is 12. So at negative 5, I have a y value of positive 12 up there somewhere. Okay, so you can do that, but often if you're good at knowing what the leading term test does, then you should be okay. So I know my graph's going to come something like that. So I think we'll call that one good. Find f of 0, in other words, the y-intercept. Y-intercept, if it's written in this form, is always this last number. So at an x of y, or a y value of y of negative 3, right there's where it crosses the axis. Done. If necessary, find additional function values to determine the general shape of the graph and then draw it. Well, it's quadratic. I'm pretty sure of what it's going to look like. As a partial check, use the fact that the graph has at most n x-intercepts and at most n minus 1 turning points. So as a partial check, it's a squared, so at most it has 2 x-intercepts and 1 turning point. There's the 1 turning point right there. I think I'm ready. So I'm going to take my graph. Let's do it in this color. Oh no, let's go green. So it's going to come down like this, reach a point, and then come back up. Something like that. Okay, so that would be the graph of that particular one. Let's maybe just quickly do another one. I gotta go to the next page here. Next page, there we go. So we did 15, how about 14? 14 is this polynomial, g of x, x to the fourth minus 4x cubed plus 3x squared. I see it, there's x squared in all of those, so I can factor that out. Be left with x squared minus 4x plus 3. That's a quadratic. That looks awfully factorable. So I think it'd be x minus 4. No, it has to be x minus 3 and x minus 1. Is that right? X squared minus... Yeah, that's right. So I have g of x is equal to that. Now, if I set that equal to 0, I think it looks like I'm skipping to step 2 here. I get so excited. So I set this whole thing equal to 0 and then solve. X minus 3, x minus 1, 0 property, so x squared equals 0, or x minus 3 equals 0, or x minus 1 is equal to 0. So in this case here, x would be equal to 0, x is 3, and x is a positive 1. So these 3 points on my graph is where it's going to cross the axis. At 0, at a positive 1, and at a positive 3. We'll put it right out there. Now this one here interests me a little bit because it's x squared equals 0. Typically from an x squared, you should get 2 results. So it's probably not proper to write them both in like that, but I guess you could indicate that at 0, there's actually 2 x-intercepts. And in class or one of the scribble casts, we said when we have multiplicity of 2, it just touches the graph at that point. So it's going to touch here, cross there, cross there. All right, let's go back to the first one. Use leading term test. Okay, leading term is this one. Let me circle that in a color. If it's x to the fourth and it's positive, that's just like this one. So it has to start high, do some bumps, and end high. Actually, 4 means there's 3 turning points, right? So it comes down. There's 1, 2, 3. So it's going to be like a W kind of graph. That's what this one is going to be. Okay, so it's even 4 and it's positive. So it starts high, ends high, has 3 turning points. Also notice that it has 3 or 4 possible x-intercepts. Okay, use x-intercepts to divide the axis into intervals. Okay, I could do that, intervals. But I know it starts high and ends high. So maybe I'll just try and draw it. At 0, multiplicity of 2. And so I'm going to come down and just kiss the graph at that point. Come back up, go back down, and then come back up. So my graph is going to look something like that. Okay, so I've sort of done that. Find the y-intercept. There's no constant term there, so the y-intercept is 0, which we sort of know that that's an x-intercept too. Done. Find additional function values to determine the general shape of the graph. I guess what you could do is, this is 1 and this is 0, so maybe at 0.5 you could plug in a number into this function and determine how high that peak goes. Similarly, if this is 1, this is 3, at a positive 2, you could plug in a positive 2 into the graph and determine how low the graph goes. So you could do that. That might help you here. And the multiplicity is zeros. We've done that, and at most x-intercepts, we've checked on that too. Okay, hopefully that helps you with a couple of those questions in 4.2.